gracefully billowing vapor from the cryogenic upper stage of the rocket poised on a launch pad is a familiar sight at the Spaceport of India, Satish Dhawan Space Centre at Sriharikota. This spaceport has seen many launches and many rockets, but this one is special. This is the Geosynchronous Satellite Launch Vehicle, or GSLV, developed by the Indian Space Research Organisation, ISRO. GSLV is a three-stage launch vehicle. The first stage consists of a solid motor with 4 liquid strap-on motors. The second stage is a liquid stage, and the upper stage uses cryogenic propulsion. It is no idle boast to claim that the cryogenic upper stage is a masterpiece in the field of space technology and engineering. The cryogenic upper stage in GSLV consists of 2 separate tanks to carry 12.5 tons of liquid hydrogen and liquid oxygen. Liquid oxygen, LOX, an oxidizer, is required to be stored at -183 degrees Celsius, and liquid hydrogen, LH2, the fuel, at -253 degrees Celsius. The major subsystems of the cryogenic engine are the combustion chamber, gas generator, turbopump, and the startup system. In spite of the complexity and challenges, LOX and LH2 are still preferred propellants owing to their efficient performance and ability to produce maximum thrust and energy required to carry heavier payloads to orbit. The efficiency of the propulsion system is measured in terms of specific impulse. The specific impulse is defined as the thrust produced per unit mass flow rate of the propellant. The higher the specific impulse, the greater the energy produced per unit quantity of the propellant. The specific impulse of cryogenic propulsion is superior compared to that of solid propulsion and liquid propulsion. The cryogenic upper stage engine of GSLV is capable of developing a nominal thrust of 7.5 tons in vacuum. Producing cryogenic fluids is an arduous task. Hydrogen is not freely available in required quantities in the atmosphere, and hence has to be produced through complex chemical processes. It is at the Liquid Propulsion System Center, LPSC, that the first steps for producing hydrogen are taken. Once produced, these cryogenic fluids necessarily have to be stored in super-insulated storage tanks in order to minimize boil-off losses. The major challenges encountered are during transportation and servicing of the cryogenic propellants. Hence, the storage tanks, transfer pipelines, and transportation tankers are carefully designed and constructed with appropriate materials. These tanks, tankers, and pipelines have double-walled construction. The annular space between the 2 walls is evacuated, and the outer layer of the inner wall is applied with multi-layered insulation, making it super-insulated. The complex cryogenic rocket technology demands a high level of skill and ingenuity from the scientists. Very few countries have achieved success in designing operational cryogenic engines. The GSLV has had 7 flights. 6 flights of GSLV developed by ISRO so far have used a Russian cryogenic stage as the upper stage. To make India less dependent on foreign launchers, ISRO initiated the indigenous development of cryogenic engine for use in GSLV. The cryogenic upper stage engine is designed, developed and integrated by ISRO's Liquid Propulsion System Center, LPSC, along with the Vikram Sarabhai Space Center and a host of industries from public and private sector. The cryogenic stage is integrated at LPSC's Mahendragiri facilities and transported to the Satish Dhawan Space Center, SDSC Shar, for integration with the launch vehicle. Shar has all the massive infrastructure facilities required to handle the cryogenic propellants. The spectacular sight of the launch vehicle holds all of us in wonder as it defies the Earth's gravity. With the power and efficiency of the cryogenic propulsion, GSLV is capable of injecting the 5 tons class of satellites into 600 kilometers low Earth orbit, LEO, or the 2-ton class of satellites into Geosynchronous transfer orbit, GTO. April 15, 2010 saw the first developmental flight with the Indigenous cryogenic stage. This was the 6th flight of GSLV, designated as GSLV D3. Regrettably, this flight was unsuccessful. The ISRO fraternity took this as a challenge and put in considerable efforts to identify the errors of the first developmental flight of the Indigenous cryogenic engine. A large number of reviews have been conducted to determine the cause of the failures and to ensure confidence for the next flight. The recommendations of all these reviews have been implemented for the next flight. The design modifications for the identified elements have been incorporated in the hardware, adequate qualification and acceptance tests have been carried out, and the stage has now been set for GSLV D5 to validate the performance of these improvements in flight. A high-altitude test, HAT, facility has been set up at LPSC Mahendragiri. This facility simulates the environmental conditions at the time of ignition of the cryogenic engine during flight. The cryogenic engine has successfully undergone ignition tests under vacuum conditions in the HAT facility. The Indigenous cryogenic engine and stage have been systematically and rigorously tested on ground to prove its flight worthiness. A large number of hot tests on main engines and steering engines have been successfully carried out. Having cleared all tests and trials, the indigenously developed cryogenic stage is now ready to power GSLV D5. GSLV D5 is scheduled to launch GSAT-14 in 2013. GSAT-14 is realized as an extended C-band and Ku-band payload spacecraft. It is configured based on standardized I2K bus. This spacecraft will have 6 extended C-band transponders providing pan-India coverage, 6 Ku-band transponders providing Indian mainland coverage, and 2 Ka beacons for propagation studies. The spacecraft is designed to be compatible with the developmental flight of GSLV D5. With a dry mass of 851 kilograms and a liftoff mass of 1,982 kilograms, with a guaranteed minimum operational life of 11 years. This indigenously built cryogenic stage has been painstakingly put together an elaborate and complex modern-day marvel down to its finest detail. It is prepared to lend its wings to carry the GSLV soaring to success as the nation applauds.